So, what the problem with curve-based sections in Revit? Glad you asked. Well, when it happens in Revit that you want to create a curve wall or any other curve-based element, you have a plenty of instruments for that, right? But when you finally need to make a draft for that element, suddenly turns out there is no way to create an arc or spline-based section in Revit. But is it even possible? You better not disturb Jeremy Zamik by asking that on Revit API forum. The answer is the same for the last 12 years.
Same answer as always. It cannot be done in Revit.
So what do people do? We users just manually draw straight sections through all the lengths of the curve-based element and then carefully attach them together, which is an additional pain as sections are not magnifying to each other during their creation. It's not pleasant, yet it's possible for a small wall or a small curve-based element. But what if the whole project has non-linear architecture? What if it's a tunnel? A dam? Sounds like a depressive caveman duties. But can we create a better solution? Yet there is no way to create a real one-piece section for a curve. Even a beginner can make a script that automates annoying caveman duties in seconds. And I will help with that. So the plan is, we will create an easy script that creates a given amount of sections on a selected curve and then place them side by side on a sheet. So they look like a single piece curve-based section we've been dreaming of. It's simple, it's effective, and it doesn't require you to be a coding wizard. There will be two parts of the video. Each video is beginner friendly, so the first part does not include any code or even a custom package. And the second part does not include custom packages as well, but we will add a little bit of code to work with lists. But don't worry, you will simply copy the minimum code. You will get all the fun without the need to study Python. This script is proven to be working on Dynamo versions 2.13 and 2.10, the most common at the moment. If you are using a different version, please check the comment for any variations or leave a comment about the compatibility with your version. And now, let's get down to business. First, we need to create a model line. You can create a model line based on some element or simply draw it by yourself. As an example, I will create a few lines. One spline, one line based on a Revit element edge. One line is a circle, just to check possibilities of our future script. And once you are happy with the result, don't hesitate to open Dynamo. Our first goal is to select the model line. For this, we search for the node named Select Model Element. You can find it in the selection menu. Here it is. Now we click Select button. Feel free to select a curve you like the most in your model. We have a model curve as the output, but we need to convert it to Dynamo curve to work with that. For this, we use node called curve_element.curve. Here it is. Now let's make them friends. Okay, so now we have the foundation on which we will create our sections. But let me remind you something about section views. As you know, the section view has a special instrument that flips section direction. Believe it or not, but we can simply reverse the direction of our curve to flip the direction of all sections. And for this, we will simply have to find a node that will reverse the direction of our line. To find it, we should type curve.reverse. But just like with this button, we need some freedom to decide if we want to flip the direction of the sections or not. So the second important node is if. The idea is that we will leave the direction of the curve as it is or reverse it if we want to flip the direction of a section. And node called boolean will serve as the flipping tumbler. By the way, we are creating our first input, so let's style it a little bit to make script more pleasant to work with. I renamed this node as a flip section direction. Then I check an input checkbox. Then I create a group and pick a color that I will use for all the inputs later in the script. Now we are ready to connect all the logic together. Our tumbler node we connect with the test input. If tumbler is in the state true, we want the script to reverse the curve, so we can add reversed curve and true. So if the state is false, we provide non-reversed curve. It's easy. Great. Great, we have a line. But I remember that we wanted to create a few sections and not just one. For this, we need to divide our curve in a given amount of lines. We will do this by taking specific points from our curve. Let's search for a few nodes. Curve dot start point, curve dot end point, and points at equal segment length. As you can see, this node takes an amount of divisions as an input. To set this amount, we search for a new node, integer slider. Honestly, talking simply, we can use this number as an amount of sections. Let's set some number and open the model. Now you can see, as in Revit, our line is divided by points. In a moment, we will use these points to create new sections, but first we need to create vectors. I search for a node vector.by2points. Vectors here are our best friends. We have a direction, which is very important when you create a section view. To create a list of vectors that will follow each other one by one on our curve, we need to prepare two lists, list of start points and list of end points. Let's use node list.create. I will include start point of the curve only in the first list, and it will be the first element of this list. And for the second list, I will include the end point of the curve, and it will be the last element. The first list only includes start points, and the second list only the end points. That's how we will save the logic. And now let's flatten it with the node called list.flatten. Great! Now we have points in the perfect order to create wonderful vectors that will follow each other one by one on the line. Let's come back now to our integer slider. So to avoid a mistake, we should set the minimum value to 1, not 0. Works great! Now let's style integer slider as an input. I rename the node to number of sections. I check that this is the input checkbox. Then I create a group and use the color I selected for inputs. And then I rename the group. Seems like we did something that makes sense, but how to create a section out of it? Let's see what instruments we have so far to create a section view. I type section view. So there is 2 points. As far as our section view is more likely not parallel to y and x axis, I found it better to use view section dot by coordinate system min point max point node. Okay, we see that this node takes 2 points and coordinate system as an input. Points, alright, but how do we create a coordinate system? I type coordinate system and open it in the tree. I need to set all the vectors for coordinate systems. So I choose a node by origin vectors that takes 4 inputs. Let's connect these two nodes. Let's also create 2 empty points for our section view node. We will come back to this later, but I think it's good to see that the finish of our script also makes steps towards the start. I create points by coordinates and leave it as it is. Once we connect them, we see a warning, but for now, it's okay. Attention! Now we will go through the most difficult part of the script. I will explain the logic, but don't bother if you don't understand it yet or don't understand it at all. Just be careful following step by step. Deal? Okay, let's go. Are you already terrified? Perfect. Let's take a closer look to the coordinate system creation node. I will take a look on the inputs. So origin is clearly a point. And what is x-axis? I'll show you on the example. X-axis is the axis that will be projected on a horizontal, a plan view. So the vector will represent how the section is placed on the plan view. In our case, vectors are perfect as they are already on the plan view and can create perfect x directions. Feel absolutely welcome to correct me or prove me wrong about any part of this video. But here, I believe it's better to first normalize our vectors before using them, so they can remain comfortable size no matter how huge our lines are. For this, I search for vector.normalized node. After normalizing, we can bravely connect x-axis and normalized vector. To keep things clear, let's create a group that highlights the x-vector. And what about y-axis? Oh, this vector represents the vertical direction of a view. If we open the section, we see that y is, in this local case, is simply going up, just like a building. So we can represent this vector as any vector that only goes up with no inclination. Irony. But traditionally, a vector like this is that axis vector. So let's find a node called vector.z-axis and connect it to y-axis. Now you understand why I wanted to highlight local direction names by creating groups, right? Let's set up an y group for this node as well. And according to the rules of creating coordinate system, the last remaining vector simply should be perpendicular to the both vectors that we already have. It's easy to receive the last vector simply by making a cross product of vector x and vector y. I search for vector.crossNode, provided with our x and y nodes as inputs. Now let's highlight that it's z vector. And let's connect the last vector. As you see, the last remaining input is the origin. Let's connect it with the start points. This way, each coordinate system that we will create will follow the direction of the vector of the divided line and starts at the beginning of this line. Once again, don't worry if you don't understand everything completely, just be sure to follow the steps. Now, let's finally get rid of the warning in the section view creation and create our first section views. For this, we should provide it with correct points. Let's dive into logic. For these points, we should provide coordinates values in our new coordinate system, which means that the minimum point should have the coordinates of origin 0, 0, 0, and the maximum point will have the section length as a value of x coordinate. There are plenty of ways to find the length of the section, but I prefer using the node called vector.length. I connect it to the original vector, not normalized, and connect the length with the x coordinate of the max point. Now the most fun part. Here we should create two important inputs. Both of them will be integer sliders. Let's rename the first to the section depth and style it as an input. You already know how to do that. This node will be connected with z coordinate of the max point. Because as you remember, that direction stands for the depth of the view. Now let's create the second integer slider. Let's connect it to y coordinate and name section height. You might also remember that y direction stands for the height of the view. Then style it as an input. And don't forget to check the checkbox that this is an input for both of the new created inputs. Oh no, we can still see the warning. Well, that's because the section height can't be that small. Let's be a little bit more careful with the numbers we set and put some values that make sense. And boom! Sections are ready. Let's check them. Perfect! I hope you see the same things that I see. Now, let's change our inputs to see how they change the sections we create. If you Dynamo run scripts in automate mode, you can play with number of sections, and as you see, it works perfectly. And now let's play with the depth of the section. It's quite small now. Let's make it a little bigger. What a magic! Now let's make it tiny tiny. Okay, feel free to set the number that works best for you. Now let's also customize the best section height. I set 3000 and now let's check it. As you see, the height changes as well. Our magic works. Of course, we can already be proud and totally happy with the result, but I want to provide us with a little bit more of freedom to set the direction of the section. Honestly speaking, we create a workaround to prevent the mistakes connected to the wrong direction of the view. For this, we create another boolean. Let's also rename it to the flip x direction. And don't forget about the checkbox. And of course, style it as an input. Just like before, let's create the if node. We connect the tumbler boolean to the test. If we want the x direction to be flipped, the node will output the second list of points. Otherwise, it will output the first list of points. And the result we connect to the origin input of the coordinate system node. And our final step in the workaround is to make the same logic to reverse the original vector. So let's make another if. I will clean the space a little bit. I connect the same boolean with the test of our new if and connect vector by 2 points to the false. And the output I connect to the vector.normalized. The only thing remaining is to provide the true input. I search for the node called vector.reverse and connect it with the node vector by 2 points as an input and true as the output. Let's check how it works. Great, even this workaround works as it should. And now let's test our script on the other lines from the beginning of the video. Wow, what a crown! And this line of sections also looks gorgeous. I believe it's a good practice to clean and style your script in the end. So next time you open it, you will understand it perfectly. And don't forget to set up our very first node as a special input to select a model line. And that's it! We automated the creation of sections with only 28 nodes and vanilla Dynamo. You've done a great job. It's been a pleasure working with you on this. And we're just getting started. So want to place sections on a sheet? Don't miss the next part. See you and happy Dynamo scripting.
Thank you for watching.